right, thank you so much everyone for coming today and welcome. This is FWM313 using federated GraphQL APIs for backend for front-end architectures. And I'm Venu Vasudevan. I'm a senior specialist solutions architect with AWS. With me, I have Dan Furman, who is a distinguished engineer from Capital One, and Aaron Semf, who is a principal partner SA from AWS.
Thanks, Venu. Sorry,
Yeah.
you want to go through
I'll
the
do
agenda?
the agenda as well. So yeah, let's first talk about traditional API architectures and limitations, and then we will come to how API architectures have evolved from traditional APIs to backend for front-end architectures, then to GraphQL. Then we will also talk about AWS AppSync and how AWS AppSync can be used to run your GraphQL workloads in cloud at scale. Then we will discuss about how Capital One uses AWS AppSync in their federated architectures. Then we will talk about a federated cross-team API development with AWS AppSync Merged APIs, and we will cover some best practices followed by an exciting demo. With that, I'll hand it over to Aaron to continue this conversation.
Thanks, Venu. So to begin with, let's take a brief look at how do we get to the backend for front-end pattern by understanding what it is that the backend for front-end pattern is solving. So traditionally, with the move away from thick client into the thin client, so now that we're utilizing web and mobile devices, having a singular API backend made it a lot more cost efficient to be able to add additional changes into our API backend, making it easier because we no longer have the requirement for install. We're no longer installing clients onto the user environment. It's now provided through the backend, and functionality is simply produced and deployed out through your web or mobile interface. Having the one server-side API backend for multiple UIs, however, brought with it its own complexity in that now we have to account for different functionality for different devices. So the types of challenges that we faced in this type of environment are having multiple devices, such as your laptop with your browser, now requires more data than, say, your mobile device, where it would make fewer calls. Not only for the screen real estate size, where you would be displaying less data on a mobile device, but also where mobile devices are making less API calls to conserve battery. Other concerns were with modern applications, utilizing things like reactive strategies for real-time data feedback. So adding in things like WebSockets into your API and adding additional features and functionality to support real-time communications. The API backend functionality is essentially supporting multiple applications with a singular backend becomes somewhat of a bottleneck. Not just technically, but also when working within your general purpose API for all your user experiences, the functionality provided for your multiple applications means that it comes with a lot of responsibilities. The responsibilities of updating the UI, the user experience, updating the API itself, and even the downstream systems. So because of this, there's a lot of work resulting in often a breakdown of the teams between the UI. So we have a mobile team, we have a web team, the API team itself, and the downstream services team, whether it's the databases directly or other services being consumed. This can actually make the problem worse in terms of being a bottleneck, the API being a bottleneck to what it is that we're trying to develop and get out, because now the API team is in the center, having to take on all the requirements of the web team, all the requirements of the mobile team. Because I said before, the mobile device is making less queries. We're making custom resources in the API backend to be able to specifically provide the data that only the mobile needs to be able to reduce that. If that were something, as often was the case, that's added later where the application is generally developed as a web-first approach, it means that we're trying to add additional capability, additional functionality into the backend without affecting the deployment of the front end or making breaking changes to what we've already deployed. As well as the API backend team is also in the middle again, having to update or make changes based on the downstream services. So other APIs that we're consuming, other databases, other changes that require additional functionality, all being brought into the API backend, making it again that bottleneck. Also, not just on a workflow and capabilities point of view, but also from a technology point of view. Traditional API limitations in terms of REST in this case are things such as loading data sequentially. When working with REST APIs, I may need to make a query to, here I've got products. In the web view of my application, or from the web application, when I make a request to products, the data that I receive may be everything that I want to display on my page, but if I make that same query for my mobile device, clearly, as I said before, the mobile device itself doesn't have enough screen real estate, so it's going to reduce the amount of data that it wants to display. Now, with REST APIs, the response that we're getting from the query is static, irrespective of the device that it's coming from. So we're making a query for our products, we're getting all of our data, and then based on the mobile device in this instance, we're just dropping away all of the static data that we don't need to display only what we want. So this is called, beg your pardon, this is called overfetching. The same thing applies in what we call underfetching when we're doing our querying sequentially. If I make a query to product and I get some product information that doesn't have the order information associated with it because I've already added it to an order previously, I'm obviously going to have to make another sequential call to my orders. The order query that I get back may again have very limited data in terms of what I need to display, because I might actually want to display the cart information, but I don't have that in the order information, but I need the order information to make that third query to get my cart information. So this is what we call underfetching, because now we have to make multiple queries to get the data that we want to display, irrespective, again, of the device. So either or, mobile, web, no matter what we're doing with REST, it's always going to be a static response. So the backend for front-end pattern it essentially refers to having one backend per user experience, instead of having only one general purpose API. So this is where the backend for front-end pattern comes in to support essentially solving these issues that we've just discussed. To address the challenges of overfetching, underfetching, everything we've just discussed, we look at a backend for front-end pattern as essentially two components. We have the front-end client, which is our web or mobile. That's our user experience. And we have the backend that is specific to that user experience. So now all functionality in the backend is only specific to that client. Now, in the REST-based environment, when we're working with our static requests, now we can make our mobile-based response specific to what we're displaying on the mobile without affecting our web client that's already developed. We can make our changes and push them out into our specific backend to support our specific user experience. So the backend for front-end pattern is essentially tightly coupled to the actual user experience itself. And by focusing on a single UI, it allows the functionality to be specific to that specific user experience, irrespective of the device. And therefore, obviously, the development required is a lot smaller or less affected. We're removing the bottleneck because now the actual development team are managing the actual UI experience and the backend experience and not separated out into multiple teams. So there's now no longer a requirement or a reliance on cross-team communication to add additional functionality into your application for your user experience. You're focusing specifically on what it is that you are providing functionally back-end and front-end. So many of the difficulties that we've solved through the back-end for front-end pattern is a physical architecture way of solving the problem. However, there's another way of solving this problem through a protocol, and we call this protocol GraphQL. Very simple slide, it's a very easy takeaway. So this other way of solving these problems comes down to the query or the data-related and query approach of querying a API through our GraphQL protocol. So the GraphQL and REST obviously are very similar approaches. They have some very distinct differences. They are essentially the foundation of many of our modern applications. And the similarities are what make them great in terms of they're both stateless and they're both over HTTP, so it makes them easy for web and mobile development. A client sends an API request to a backend and receives a response, or to an endpoint and receives a response. And the server gives the response that contains the data, the status, or error codes that that requesting client needs. These are the similarities, and these are the things that every application needs across whatever protocol we're using. However, in their differences, REST, essentially, for those of you familiar with REST, are using multiple endpoints in terms of resources, and then multiple verbs to understand what it is, the type of request you're making. If I'm making a request for data, I may be making a GET request on a specific resource. If I need my orders, it may be my endpoint/orders/GET request to get that data, but then I may be creating an order, so I'm now doing a endpoint/orders/post to post data. The difference here with GraphQL is that we have one endpoint, and we're using the pattern CQRS to distinguish whether we're making our query, whether we're making our mutation, which is our post or creation and modification of data, or whether we're making subscriptions. So that's bringing our real-time data into that functionality by default. In REST, the URL identifies the resources that we're trying to retrieve. In GraphQL, it's the same endpoint post again, but it's the data in which we're sending in our request that specifies what are the resources that we're trying to retrieve. And finally, in REST, we're utilizing parameters and values based on either in the query string or in the post request, based on the verb that we're sending to action different actions, to fire off different actions within our backend. However, within our GraphQL, we're using post data, so it's all in the post body to describe what it is that we need to do and what the server needs to do to hand us back the response that we expect. And it's the differences here that make up the difference. So while the backend-for-frontend pattern helps to solve the issue of the general purpose API by pattern, GraphQL helps provide a solution through protocol. So the GraphQL itself is agnostic. As you can see in the backend square here, GraphQL is agnostic to your downstream data source. It abstracts away the ability to provide a singular interface for multiple different data structures, data types, whether it's another HTTP API, whether it's a direct data source like SQL, NoSQL, a key value store. It doesn't matter what it is. It creates an abstraction layer that allows you then to query and provide a unified response back from an application point of view. So now your front end can make a query, reducing the amount of requests. So it's now no longer a static request saying, just give me a resource and I'll take everything. You're able to describe in your post what it is that you want to receive. Based on what it is that you want to receive, the GraphQL backend will then distinguish what are the data sources downstream that I need to query to bring together to make my application response and hand it back. So we're able to connect multiple data sources. We're able to retrieve and respond with real-time data to reduce the delays and essentially eliminate polling, where we need data on the fly, where in a REST-based environment, we'd have to be making multiple requests. And we can reduce and control the amount of data that we're actually sending. So now in the same query, we can use the same query for both web and mobile, but select what it is that we want in our response so that we only have the data that we need. So the backend for front-end pattern with GraphQL seems like the next evolution in APIs, moving the power of querying the required data specific to the user experience into the client itself instead of within the backend. However, this in itself brings its own concerns. The first concern here is duplication. When we're creating our application, our GraphQL schema, to specify what it is that we want the queries to retrieve. So if we've got products and orders and we've specified the object model that we're handing to our application, when we start to separate out and look at the backend for front-end pattern, and we're doing the same thing for mobile and web, now we may get a duplication of our schema. So we're now creating duplicate models. Another is the concern of the API endpoint and the multiple domain management. So with the backend for front-end pattern, we're used to having multiple endpoints specifically for a different device. We'll have a mobile device, we'll have a web device, so we have a different endpoint for each. Both of these concerns can be solved with GraphQL. So obviously the easy one is the endpoint concern and the multiple domain concern. Now, irrespective of your device, you're all pointing to the one endpoint. However, for taking advantage of to resolve the challenge of creating multiple schemas or multiple models, this is where GraphQL federation comes into its own. And so teams that are developing specific functionality for their applications can create the models that they need, but now in model federation or GraphQL schema federation, they can share and query the schema or the models that their teams, the other teams developing the other UI experience are developing as well. So this is essentially a theoretical look at, how do we bring in the backend for front-end pattern and utilize GraphQL to solve some of these challenges. But Dan, how would we actually do this in a real-world situation, bring this into operations?
Thanks, Aaron. It's a fantastic question. So the way we approach looking at the GraphQL solution, we need to find a way for the GraphQL workload can actually scale data in the cloud. It needs to be secure. It has to be scalable. It needs to be integrated. We want good return on time. It needs to be maintainable. And we want flexibility in it. But what we want to make sure that we optimize for is that return on time. Because what matters to the customer at the end state of this is that the value is brought from the user experience, not from the amount of code that we manage. So there's multiple options that could fulfill my needs. I could build this in-house. GraphQL is an open specification. We certainly have the ability to have people go read that spec and start coding. We could use an open source framework. There's one in any popular language today that supports the GraphQL specification. We could use a vendor product, or we could run whatever we need to. We could do this in a container. We could do this inside a Lambda function, or we could do this inside of a managed service. But again, what's going to give us the most return on our time as we're looking at this data? What we want to do is connect our application to the data and make sure that that is what we're indexing that approach for. While all of those can fulfill your needs, optimizing for return on time gives you a force multiplier. And here's where AWS AppSync comes into the picture. By giving us more customer value per engineering hour and giving us a logical way to break down all of the problems that Aaron talked about, we have the ability to then deliver customer value iteratively and without the complexity of managing that code ourselves. So what is AppSync? AppSync is a serverless and managed service that runs your GraphQL workload natively in the cloud. We can break our development into the data itself, the schema, what is available to happen, how do we secure that data with an authorizer, and we can do that through native integrations through AWS, or we can do that in custom logic that we write ourselves. We want to look at how do we get that data. This is where resolvers come into the picture. This can be done via Lambda functions, via JavaScript native resolvers that run directly inside the AppSync runtimes, or we could use a native integration. We want to look at where the data is stored. These are sources. Like I said, we want to map the application and the data to the cloud for what it is that we need, and we want to do that at the field level. That way, I can nest this data the way that it makes sense for the UX experience and make sure that we're giving what is necessary to the front-end development team, to the mobile team, to the web teams, to be able to make this happen without coupling these together. AppSync allows us to connect that data directly in AWS using GraphQL. So let's talk about a direct example here. How Capital One uses the AppSync backend for front-end pattern, and we'll talk about Capital One Dining. Capital One Dining is a reservation platform. It provides rewards cardholders with culinary experiences that are exclusive and sought-after reservations. These happen at top-rated restaurants. To do this, Capital One exclusively teamed with acclaimed chefs like Jose Andres or Dominique Crenn, culinary titans like the Michelin Guide and the James Beard Foundation, And with the help of these partners, we've been able to provide cardholders the ability to get their hands on hard-to-get reservations at the carefully curated list that now includes more than 450 restaurants in 16 cities across the continental United States. So as we talk more about the UX that we're unlocking, the best way forward, in my opinion, has always been an example. I know this is true for me. I know it's lunchtime, and reInvent's been amazing, but it always helps me work up an appetite. So let's use me as an example customer. As we were prepping for this talk, I started thinking about what does the schedule look like to grab a nice meal for tonight. A few weeks ago, I actually booked my reservation, and I'm really looking forward to it. So let's break down how Capital One Dining enabled me to do this and what it took to be able to do just the simple things that we see on the screen now, selecting my date, selecting the time, and selecting how many guests I have for my reservation. We want to go through the flow of the application here. The user needs to interact with the content delivery network and actually pull the information down that makes their user experience come to life. Within that is going to be the front end and web assets that will make those things come to be. But for any of the dynamic data, that's where we're going to the backend for front-end pattern, and the user is going to directly interact with this. We want the authorizer to be able to be invoked immediately and decide whether or not we can use the service. I need an integration to my internal rewards data to be able to know that what my reward status is within the certain boundaries and wherever the parameters that we set are. And I need to know the current restaurants in the city that I've chose to specify. Then I need to know the available restaurants at the date and time and the tables for those hours. So how do we do that? Putting this together through a backend for front end eliminates any kind of blocking orchestration service that we would have used in the prior days to be able to make this happen. We can instead manage state and gracefully handle failovers within the AppSync environment. We want to focus specifically on the Capital One user dining experience. We're not building and maintaining code that's just running these long-running servers. We're not maintaining our own web sockets. We're not having to deal with those direct security updates that need to be applied to those processes and then needing to do cutovers, canary routing, and all of that. We have the ability to offload all of that into the cloud and focus instead on bringing that data and our applications together to make those drive home. We want to make sure that we eliminate those extra XHR and fetch calls. We make single GraphQL queries, and this eliminates the overfetching and underfetching. I can pull exactly what I want, and if I'm on the mobile client, I can pull a much smaller payload that doesn't need to populate anything else other than what my user's looking at. And if I'm on something that is a web browser or UI, I may get some additional data that would help me for additional use cases. But those are all defined by that backend for front end. So the changes here are decoupled from the release and that they focus on the user interaction driven by that user experience. GraphQL allows us to bring these together within that single API and match that UX need specifically. For the backend for front-end developers, we want to decouple them from the release timelines. The closer we get to being able to give them immediate time to delivery and market, and then allow the user experience to implement where it needs to, the faster we're able to do this. So for example, slower moving events like addition of new restaurants or addition of new partners into the service can be done by events and directly integrated with DynamoDB, whereas logic like being able to reserve a table or manage a reservation is more directly managed by our code and where we're bringing things in. This logically lets us break the service into different sets. The authorizer, again, gives me the fact that I'm a current customer, allows me to use the service, and make sure that what I'm doing is enforceable. So this is something that follows the AWS shared responsibility principle and that thing that we've come to know and love, that an explicit deny will override any implicit allows or explicit allows that have happened. This allows me to protect the schema from any manipulation that's gone into point and allows me to have verifiable enforcement. The verifiable enforcement is key for a PCI DSS compliant organization. Resolvers are dedicated to specific relationships in the graph, and the AppSync logic becomes the heart of our development time in the resolver. So we can directly integrate where we need to, we can use Lambda or the native JavaScript resolvers where we need more flexibility, And we can build the connection between that data to force what we need to happen at a specific date time. And we can decouple those developers from that. So all of this allows us to split the team's responsibilities together, decouple them from each other, and drive those new customer user experiences. Without things like backend for front end and using technologies like AWS AppSync, Capital One would not have been able to bring dining to market in the short time that we were able to do it. Venu's going to talk about one of the features that really has me excited in AppSync. This will allow me to further decouple these teams and bring an actual logical and physical separation of my graphs without any incurred performance penalty and let the teams further increase their efficiency. Venu.
Right. Thank you so much, Dan. And special thanks to you for booking a dining reservation for me and Aaron tonight using AppSync and Capital One Dining. So that's really great. So let's talk about merged APIs, federation. So Dan mentioned about few opportunities in his architecture for the individual teams to develop the APIs separately, but yet combine them and expose that as a unified schema to their end clients. So let's talk about federation and AppSync, how AppSync helps in that federation. So first, let's talk about some requirements for multi-team API development, right? So multiple teams working on a single schema have always run into few problems. Some challenges that I could describe as, one is simultaneous API development. When multiple teams are working on the same API simultaneously, could break one another's changes without having proper isolation and guardrails. So it might lead to accidental breaking changes. The second thing is support and maintenance. So no single human can understand the entire surface area of the schema if multiple data domains are there in the single monolithic graph. So this always happens, and sometimes what happens is this nightmare for maintenance and support. So to solve these challenges, AppSync introduced merged APIs. So what if we could break these APIs apart so that the domain experts could own their portion of the API and develop that independently, yet unify that schema and expose to the clients. So AppSync introduced merged API for cross-team API development this year. So what it means is AppSync actually merges the schema together. So you have individual source API, which could merge them together and then present a unified schema for the end clients. So from the front-end angle, still the clients needs to worry about only one single unified endpoint. In the back-end, the API teams could still develop, create, build, deploy individually, and when the source changes are approved, they can merge together in the merge schema. One key important thing to note here is AppSync does this at build time. What it means is AppSync does not have a gateway or router to route these requests. So at build time, these individual schemas are stitched together and a unified schema resolvers is being built. So AppSync, the merged schema or merged API already has knowledge to how to connect to data sources to pull the data. So let's take an example here, right? So I have team A developing an order API, team B developing a product API. Both are hosted in AppSync. One is connected to a DynamoDB data source. The next one is connected to Amazon Aurora serverless. In this example, my API connects to only one data source, but you might know the AppSync can connect to multiple data sources simultaneously to pull the data, even if it is hosted in a microservice or VPC or containers. It can pull the data and get the data for you. So in this case, I have order information, which is completely separate from product information. What if we could merge these two schemas together? So with the merged API, AppSync is able to merge the resources, the types, the fields, the operations, the resolver code, the function logic, the data source definition, everything is being merged together to a single unified endpoint. So on the left side, you see the unified schema where order, product information, the query information, everything is merged. And you also can see there is a relationship between order and product information where with a single API call, I can relate order and product information with a parent-child relationship to pull in order plus the product information in a single unified call. And also, the merged API schema has access to the data sources through source API using IAM permissions. Okay, so now that we talked about how AppSync merged APIs can solve the federated cross-team API development and how it is doing like a build-time approach, let's talk about some of the best practices for merged API deployment and development. The first thing is schema design. Be it you have a single unified API that you want to split across to multiple APIs, or you already have source APIs and AppSync that you want to combine together to make sure you have a single unified merged API, schema design is really important. First thing, source API. Source API means think of data or domain-driven model, right? So each domain or data domain or related domains could be a source API, and ownership maintained by a single team. A single team owns the source API. And the types and field definitions will have a unique primary key. In the example I showed, the order has an order ID as the primary key. The product has a product ID as the primary key. So defining these primary keys are really key in establishing the relationship between the source API. On the other side, on the merged API, think of org-wide use cases. So you have enterprise-wide use cases where you can relate two data domains or multiple data domains in your company together to present it to your end users. The true power of merged API comes into picture when you establish the relationship. So you have the same example I showed, order and product are related. You can pull in order information plus product information in a single call. So that's where merged API use case is really better. And in large organizations, what happens is there is always a possibility of conflicts. So you have multiple source APIs with same types, same fields, same operations. So in that case, what happens is you need to resolve the conflicts before it is getting merged. So the best way is to collaborate between the teams and resolve this conflict. But sometimes that does not always happen. So AppSync provide what we call as directives to resolve these conflicts. So you can hide fields, you can rename the fields, you can make one of them or primary or secondary based on the use case with these directives. Okay. So we talked about schema design best practices. We will talk about security best practices, right? The security best practices, again, with the build time approach, AppSync, the merged API is again a standalone another AppSync API with all the goodness of AppSync that Dan talked about. You can enable caching, you can enable tracing, observability out of the box, and also subscriptions are supported out of the box, meaning it's a standalone AppSync API. You can enable all these goodness with that. Along with that, the popular authorization methods already supported with AppSync are supported with merged APIs also. Like you can place a IAM authorization or a Cognito user pool or OIDC or Lambda authorizer for your merged APIs as well, like any other AppSync API, right? So there are two modes in merged APIs and source API. One is the primary authorization mode. So the primary authorization mode can be configured based on your use case or what your client needs are. And the secondary authorization mode could be related to your source API authorization mode, meaning the source, if the source API authorization mode has high IAM credentials to be authorized, so you can have that as a secondary authorization mode or a primary authorization mode in the merged API. So the requirement is to have the merged API configure the source API authorization mode either as a primary or a secondary authorization mode. The third thing I want to talk about is merged API execution role. So at runtime, the merged API execution role needs to have permissions to execute the queries on the data source exposed by the source API. And there are a lot of organizations where these source APIs are distributed across AWS accounts. So again, AppSync supports that with merged APIs, where you can bring in the source APIs from other accounts as well through AWS Resource Access Manager. Again, scan the QR code. We have written some best practice blog for security and schema composition. Okay, so next I want to talk about best practices on deployment, right? So from a deployment angle, what are some best practices? First things first, test the source API independently, meaning that's an independent API. So whenever you are introducing some relationship or whenever there are changes to source APIs, make sure that you test that properly. Because when merging the source API, there might be some conflicts, other things that needs to be resolved. So you need to test that individually. And AppSync provides what we call as evaluate code API to test this resolver logic before even you can stage it to production. Second thing, test the merge in a lower environment. So once you're comfortable with the individual source API, test the merge operation between multiple source API in a non-production or lower environment before going into production. This will ensure that you are resolving the conflicts by collaboration with the team or using some directives, etc. The third thing is merge options, right? AppSync provides 2 merge options. By default, it's a manual merge, meaning if there is a change in the source API, you need to manually merge to the merged API. But some of the organization, depending upon the use case, you can enable automatic workflows as well. Whenever there is a source API change, it automatically gets merged to the merge API. Fourth thing is use CI/CD best practices, deployment pipelines to deploy your source API and merged API. Again, versioning is really important here. Use a source code management system like Code Commit or GitHub to make sure that you store your source code such as resolver, schema, so that if you want to revert back to some of the previous version, you always have access to version control. The other thing is use infrastructure as code like CDK, CloudFormation, Terraform to do these deployments. Another important thing here is breaking change detection. Right? So breaking change is something like you change the return type of a field or a type, there is an option to change the adapt to the breaking change detections based on CloudFormation hooks. AppSync provides CloudFormation hooks to compare the previous version and current version of the schema to see if there is breaking change. And if there is a breaking change, it will warn you or it will fail the deployment. Okay. So now that we talked about merged APIs, best practices, let's talk about a reference architecture here. So I have a reference architecture for a recommended reads application hosted in AWS Amplify, which uses a merged API for recommending books and authors and genres based on your selected genre. So I have 4 source APIs here, all hosted in AppSync. One is backed up, books is backed up by a DynamoDB table, and authors is backed up by Amazon RDS and RDS proxy, and users is hosted in Amazon API Gateway, which is a microservice, and AppSync API uses HTTP resolvers to access them, and reviews is hosted in an AWS Lambda function. And all these 4 APIs are combined together to a merged API, and using a Cognito and API key as the primary and secondary authorization modes. Again, scan the QR code. We have a wonderful workshop that can walk through deploying this entire architecture for you. This is another version or slight variation in the reference architecture I showed, where we introduced access for API access from AppSync to Amazon Aurora Serverless v1 through Data API. So using Data API and JavaScript resolvers, you can connect to Amazon Aurora database now. And it also has an introspection facility where you can introspect your RDS schema and generate AppSync APIs out of it as of a couple of days ago. Okay, so we talked about reference architecture. Now let's talk about some of the approaches in the federation. So we talked about the merged API approach, which is a build time approach, where everything is constructed at build time. So essentially, the standalone API which is created is essentially another AppSync API with all the bells and whistles of AppSync, and with subscriptions, everything fully supported out of the box. There is one more approach called gateway approach, where you can front all these API with a gateway or a router, right? So with that, any execution query or any execution request which is coming in, there is a runtime decisioning happening. So with the router, there is a runtime decisioning to go to which source API to pull the data. Again, there is always a question, which approach should I use for my organization? Again, this is not an either-or choice. You can also use both approaches in conjunction. It depends on your use case, right? So the use case is if you have AppSync APIs and non-AppSync APIs in the mix, go with the federated gateway approach where you can federate to multiple AppSync and non-AppSync APIs. And if you have only AppSync APIs in the mix, you go with the merged API approach. Here I'm showing two examples. One is through Apollo Federation and another is through GraphQL Fusion. So Apollo Federation, again, it's one of the popular frameworks a lot of customers use where to federate to your AppSync and non-AppSync APIs. You can even federate to merged APIs as well. And GraphQL Fusion. So GraphQL Fusion, so AppSync is a proud contributor of GraphQL Fusion. It's an open source specification that we released this year at GraphQL conference. So it's community driven. Again, you can integrate APIs using GraphQL, REST, gRPC with that. And this reference architecture here shows GraphQL Fusion running in a Fargate container, which is connecting to one of the open source GraphQL running in Lambda or API gateway, another two GraphQL APIs as well. With this approach, you can combine these two AppSync and non-AppSync together with a gateway approach. Again, depends on your use case, whether you have what kind of APIs in your mix, you can choose to go with either of the approaches. Okay, with that, I will go with a demo. Again, the demo is based on the reference architecture I showed with the 4 books, authors, users, and reviews API. All right. Okay, let's start with the demo. This is a recommended reads application with 4 APIs, books, authors, users, and reviews. And let's go to the console to construct a merged API out of these 4 APIs. So I have everything deployed with CDK. And let's create a merged API with all these 4 APIs. So I select merged APIs and click next. I call it recommended reads API. I also give a contact details. So in case who's the owner of the merged API and the source APIs, I can give a contact details for the API. I'm creating the service role that we talked about to have access. I can mark this as a private API if I want. I'm correctly selecting these APIs from the same account, and I have an opportunity to select that from the different account as well through AWS Resource Access Manager. Click next, and I'm selecting API key as the primary authorization mode and additional authorization mode as a Cognito user pool. All right, I'm reviewing everything, make sure everything is okay, and then creating that API. It'll take a couple of seconds to create that API. So once it is created, let's review the schema. Let's review what has been merged. Okay, so all the things are merged successfully. So let's review the schema. So as you can see, the author, books information from all the source APIs have been merged together in a single schema. And all the data source definitions and all the functions, all the resolver logic, everything, AppSync takes care of merging it for you. And the queries and mutation from both these APIs are already available for you to access. All right, let's make a change to the source API to relate these data together. So as I said, the true power of merged API comes into picture when you relate the data. So let's relate the books API and author API. So to pull all the books information for a particular author. Let's go to the books API, and let's add a type called author, where I'm passing an ID plus a book information, like a book connection, where it will retrieve me the list of books. So I'll save the schema. And then I'll create a function now to access the author ID from my books and get the list of books for that author ID. I'm creating a function here. It's a JavaScript function. Again, it's called getBooksForAuthor. So let's do that. Let me copy paste the code. So what I'm essentially doing here is, from the context information, when I call get authors, I'm passing the author ID and getting the books information for that author ID. All right, let's save it. And I'm going to create a resolver to call that function for the newly created type. So JavaScript resolver, I'm going to create it, and then adding that function. Again, this example is available as part of the workshop as well, so you can go through that. Right? So now let's go back to the merged API and then re-merge it again, so that since we have changed the books API. I'm going to do merge now again, so the changes are getting reflected. So the merge is success. So the new changes have been merged to the merged API again. Here I'm following a manual merge, but you can do an auto merge. As you can see from the queries, if I expand the list of authors, it already has the books information now. So with a single query, I can retrieve the books as well as author information. So let me select book fields and author fields. And then let's run it. So as you can see from here, with a single call, I was able to retrieve the book information as well as author information. So basically, I related these two data together to get everything in a single call. I'm just showing an example here to relate a couple of data elements, but you could do that with multiple data APIs and data sources as well. As you can see here, I unleashed the possibility of combining multiple APIs in a single call, so that you can call that API to get all the related information you want. So as Aaron talked about the evolution of architecture, we started with a traditional API, then to the microservice architecture. We split them together. We split them apart, and that had its own limitation. Then we came to the backend for front-end architectures, and with GraphQL as a protocol that solved the backend for front-end architectures. And after that, as a next evolution, we have the federation. And if you want to run these workloads at scale at AWS AppSync and is a great companion for you to create these APIs and run them together. With that, that's it for my demo. And again, thank you so much. So I'm really excited to see what kind of backend for front-end architecture that you can create with this federated API architecture. And here are our social and email IDs, and that you can connect with us. Or if you have any questions, please let us know.